Please excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally. Yeah, so Pemdas is going to be super important when we're solving two-step equations, which is what we're doing today. We love Pemdas. We know Pemdas. We love Pemdas. Pemdas is our friend. Please excuse my dear Aunt Sally. It stands for the order in which we evaluate functions. Parentheses first, then exponents, then we multiply or divide, and then we add or subtract. Now, if you notice, that word is evaluating, not solving. If you see this first example, it says evaluate 3x minus 4 when x is equal to 5. That means I'm going to take this value of x right here, and I'm going to plug it in to that equation, and I'm going to evaluate. So instead of this saying 3x minus 4, what am I plugging in? Okay, evaluate means plug in. What am I plugging in instead of x? What number does it say? 5. Okay, cool. So I've plugged in a 5. And I'm going to start evaluating. Is there anything inside that parentheses I need to take care of? Can I reduce the parentheses at all? No. Are there any exponents? No. Can I multiply or divide something?
Yes.
Yeah, the 3 times the 5, right? It's going to give me 15. And then I can add or subtract, right? 15 minus 4, that's 11. That's what we did when we evaluated functions. Okay, we plugged it in. And then we evaluated. We used Pemdas. But when we're solving, if you notice the verb in the second equation has changed. The verb now says solve for x. We're basically doing reverse Pemdas rules, which means we're not starting with multiplication and division. For a two-step equation, we're actually starting with adding or subtracting. So here are the steps you're going to do. Number 1, draw your line down the center of your equal sign. It creates a left-hand side of the equation and a right-hand side of the equation. We are then going to either add or subtract numbers to create inverse operations that then isolate our x. Plus 4. Now, why did we say plus 4? Plus 4 is correct, but because it's negative. Now, what I do to one side, I got to do to the other, which gets rid of the minus 4 on the left-hand side. Leaves me with 3x equal to 15. Currently, on this left-hand side of the equation, what is happening right here with these 3 and x smushed next to each other? Yes?
I think are you asking me the whole, the rules to it? Or
Well,
or
right here, what operation is happening? Am I adding, subtracting, multiplying, or dividing? Multiplying. When 3 and x are smushed next to each other, they are multiplied. What's the inverse of multiplication? Division. So I'm going to divide by that number that I want to get rid of so that I can isolate. And what I do to one side, I do to the other.
I remember this in 6th grade.
Yeah. Remember, we are no longer using this division sign. Don't use that anymore. We're using fraction bars to show division. Yes, does this look like things that are familiar to us? We're going to go over these inverse operation steps, this reverse PEMDAS essentially, on this front page and some examples. We're going to do some I do and then some you do. So follow along with me on the number 23 as we do this one together, and then I'll have you try one on your own. We just said a second ago to solve for x, to find the solution. We're going to start by creating two sides of our equation. So draw that line. Right now, this example says 3x plus 6 equal to 21. I'm going to isolate the x by doing reverse PEMDAS, inverse operations. Currently, you see plus 6. Subtract 6. Very good. That's its inverse operation. But what I do to one side, I got to do to the other. Yeah, you're right. So this is just 3x and 21 minus 6, which is 15. Now, what is currently happening on the left-hand side? Multiplying. What's the inverse of multiplying? Division. So that's what I'm going to do. Yeah, this problem is very similar to the one just a second ago.
It'll be x equals 5.
Correct. That's the solution. So don't call it the answer anymore because we're solving mathematically. That's called a solution.
Oh.
It is the value that makes the equation true.
Same thing. It's just like just opposite.
Correct.
Okay.
Yeah, so solving is reverse PEMDAS, and if we wanted to check our work, we would just plug that number 5 in for x in the original equation to try to see if it is actually equal to 21. And we can toss that into a calculator to double check that our work is correct. That's a true mathematical statement, 21 equal 21. That follows PEMDAS rules when solving followed reverse PEMDAS rules. Okay, you guys try number 24 for me, please. I'll give you like a minute or two to try to do question number 24. So here's the work again. One more time, we'll just go through it. We started off with 4x minus 7 equal to 17. We do the inverse operation, which is adding. Combine like terms, 17 plus 7 is 24. Divide, because the opposite or inverse of 4x, that's 4 times x, is to divide by 4. Divide by 4, we would get the solution of x equal to 6. Cool, let's go to the next one. So the next one's kind of really cool, because if you look at example 25, some people might be like, ooh, a fraction. Don't worry. Remember, we talked about fractions being actually just division. So what we can do on this one is just like the other one. Start with your line. Reverse PEMDAS means I'm going to take care of adding and subtracting first, which means, am I going to add 5 or subtract 5 to both sides? Yeah, great. That's the inverse operation. I'd be left with x divided by 4 equal to negative 3 plus 5, which is 2. Don't let arithmetic be the reason that you're getting these things wrong. You have a calculator for a reason. I would love for you to try it in your brain and check it in a calculator, but don't let that be why you get these problems wrong. Now, last class, I made a big fuss about this symbol right here. How did I tell you to say this?
X divided.
X divided by 4. So if we change our phrasing from x over 4, which is correct, there's nothing wrong with that, to x divided by 4, it lets me know what's going on here. What's the inverse of divided by?
Multiplying.
Multiplying. So this is how we show multiplication. Remember, we're going to put everything in parentheses, and we're going to multiply by that denominator number.
So that'd be, isn't that also like 25, something like that?
So 4 times 2 is all we have to do there.
Oh, okay, so that'd be,
4 times 2 is 8.
oh, 4 times.
All right, let's check out 26. Hopefully you did this one on your own. Is this what you got, negative 36?
Yeah.
Yeah, so let's talk about these steps one more time. What's the first thing I did? You tell me. Subtract it. Why did I choose to subtract 4? Inverse operation. Great. So negative 8 minus 4 is negative 12. What did I do in blue now? I multiplied. Why did I choose to multiply? It's very cool. Yeah, no, great. This is already divided by. X divided by 3. The inverse of divided by is to multiply. So I multiplied both sides by 3, which got rid of that denominator. And I ended up with the solution x equal to negative 36. Okay, cool. Great. Awesome. Let's go on to examples 27 and 28. Now, the reason why these examples are 27 and 28 is because your last homework or your last notes actually ended on 22. Don't just think it's like a random number. What do you notice is now happening with example 27?
It got decimals.
It got decimals. Okay, that's one check. What else? There's parentheses, and there's a number in front of that parentheses. What does that mean I have to do with that number in front of parentheses? We just did a Kahoot with this. What is that called? Distribute. Distribution is a multiplicative property. So we're going to multiply to distribute that 1.25 to both of the numbers. Again, here's the thing. Do not let multiplication and division, addition and subtraction, that's arithmetic, be the reason you get this wrong. You have a calculator. So you guys have got calculators for this. We're not going to get stuck on it. But when we do this, we're going to get 1.25 times 8x. That's 10x. Oh, that's nice. And then 1.25 times negative 5 is negative 6.25. Don't let calculations be the thing that messes you up in algebra class. Okay? What should I do next now? Now that I've done this distribution, doesn't this problem look like examples 25 and 26? Yeah. What's my next step here to continue to solve? Add 6.25 to both sides. I'm going to get 10x left over equal to 13.75 plus 6.25. That's a nice pretty 20. Check a calculator if you're not sure. And then what's the last step to continue to isolate for x? Divide by 10. Great. Now here's something I see students do a lot that I want you to avoid. Don't do this. What did I just do?
Put the 10x.
Yeah, we're not dividing by 10x. That's actually called a rational function. You learn about that in Algebra 2 and pre-calculus. But that is not what we're doing. We are just dividing by the coefficient so that the coefficient will disappear. Don't divide by the x. 20 divided by 10, that's 2. Okay, we've got one more example on this front page for you to try. If you have questions about 27, ask them now, because you guys are going to try 28. Do not let arithmetic be the thing that messes you up. You have a calculator. Go ahead and try 28, please. Okay, let's talk through this last problem just one more time. I just left my pencil over here. So we distributed, that's multiplication. 1.75 times 4x is 7x. 1.75 times negative 8 is negative 14. Okay. Now it's a two-stepper. Once we've done distribution, it's just a two-stepper. We're going to do the inverse operations. You're going to add 14 to both sides. Negative 7 plus 14 is 7. And then you're going to divide by that coefficient, because right now it's 7 times x. The opposite of multiply is divide. 7 divided by 7 is 1. Woohoo! This next section is about equations with variables on both sides. Circle where it says variables on both sides, please. So if you notice, every single one of these questions on this side has x's, or whatever letter we're using, on the left side and the right side. That makes these multi-step equations. When you're doing multi-step equations with variables on both sides, I teach something called the box method. Okay, this is probably something you've never seen before. It is a very helpful tool for any visual learner like myself. So if you are a visual learner like myself, you might really, really like this. If I show you this and you're like, honestly, I just like inverse operations, which is what I learned last year, go ahead. I'm not going to force you to do this one. But today we're going to work on it together. Now what I want you to do is I don't want you to pick up a pencil right now. I just want you to watch. Okay, so put your pencils down. I will give you time to write this down, but you're just going to watch it first. When I'm going to solve the equations using the box method, because there are variables on both sides. That is a crooked line. Let me try that again, because that's embarrassing. Okay, take 2. You're still going to start the exact same. You draw a line down the center of the equal sign, and you look for distribution. There are no parentheses in this one, so there is no distribution. Instead of starting to do inverse operations, remember your pencil is down, just watch. You're going to set up 2 boxes. Each of these boxes on the left side and the right side has 2 rows. We do this to create a place for each and every one of our terms to go. There are 2 terms up here with letters in them. Do you agree? You have this term and this term. That means there are 2 boxes on the x side of my equation. Okay? There are 2 terms up here that are good old-fashioned numbers called constants. Do you agree? That means there are going to be 2 top boxes on my number side of the equation. This gives me a goal of where these numbers are going. So I'm going to take the 5x and I'm going to drop it down into its box. It stayed on the left-hand side of the equation, so it stays 5x. But when I drop the 3x into its box, do you see how it had to cross over that center line from the right-hand side to the left-hand side? When that happens, I'm going to have to use its opposite term. It's 0 pair. Basically, it's inverse operation. It was positive over there, but because it crossed over the center line, I use its inverse, which is negative 3x. I do the same thing for the for the constants. This 1 needs to go right here. Should I write down positive 1 or negative 1? Negative. Great. And then I'm going to put the 5 right here. Do I need to change that one sign? No, it stayed on the same side of the equation, so it doesn't have to change. If you notice, all of my like terms are together now, correct? That means all I'm going to have to do is combine my like terms, which means I'm adding the numbers in the top of the box to put them in the bottom. 5x plus negative 3x is 2x. And negative 1 plus 5 is a positive 4. At this point, it kind of looks like the end of a regular two-step equation. Right now, we have 2x equal to 4. So we're going to divide by that number in front of the x to get our final solution of x equal to 2. That's the solution for this. That's the solution we would have gotten had we used inverse operations, but instead I used the box method. Take a second. I want you to pick up your pencils and write this one down so that you can have this on your notes, and then we'll try the next one together. Here goes number 30. The first thing we do is we draw my line. Phew. Next thing I do is I look for distribution. Is there any distribution in this problem? Like, are there any parentheses? No, so we can skip that step. Yay. We're going to set up our boxes. So we have a box with 2 rows equal to a box with 2 rows. Make sure you put that equal sign in the middle of them. That's super important to me. How many x terms are there? 2. How many constant or good old-fashioned number terms? 2. So there's 4 top boxes for my 4 terms in this equation. Let's start putting them where they belong. I want you to draw the arrows. Where does this 7x belong? Over there. X's all go to the left-hand side. It's 7x. Where does this 2 belong? On the right-hand side. Yeah. Do I need to change its sign? Yeah, so it was positive, so now it's negative. I just use the inverse when it has to flip from side to side. So that needs to be negative. Okay, now this 3x, I have to move it to the other side. This is why drawing the arrows is important, because it's crossing that center line. If it crosses the center line, you use the opposite term, so negative 3x. Do I need to change the sign of that 14? No. Did it change sides? No, it stayed on the right-hand side, so we're okay. What did I do next to create the bottom? I added them. I'm going to CLT. Remember, we're going to combine like terms. Well, they're all right there, so we're going to add these things together. 7 plus negative 3x is 4x. And negative 2 plus 14 is 12. I'm just adding like we did before when we combine like terms. Right now, my equation says 4x equal to 12. So 4x means 4 times x. What's the inverse of multiplication? Division. Divide by 4, divide by 4. This is going to be x equal to 3. Yes? So here's what we're going to do. I'm kind of going to let you go to numbers 31, 32, 33, and 34 at your own pace. You have a partner for a reason, so you may use them for help. You also have 2 teachers for a reason. You may use us for help. I do not want you to do the last 2 on this page. We're going to skip those. So if you are wondering while you do this work, again, I don't really care about the final answer right now because it's our notes. I just want to make sure you can do the problems. So in fact, I'm going to give you the answers here. I don't really care that you wrote it down. I care that you know how to get it. So the first, number 31, you should get 4/5. Number 32, you should get 2/5. Number 33, you should get 4. And number 34, you should get -3. Up to you to figure it out, though. I want you to do the work with your partner to make sure you know how to do this. Yes? If you want to use inverse operations, you can. If you like this box method, whoa, what words just came out of my mouth? If you like this box method, you can totally use it. I just squished all those words together. Okay, y'all go ahead and give it a shot. I want you to work. Here we go.